Have you ever wondered which is the best cooking oil to use? Palm oil, olive oil, canola oil. Which cooking oil is good for you? Which oil is best for frying? Which is best for salad dressing? And which is best for which? All cooking oil are composed of 3 different types of fatty acid: monounsaturated, polyunsaturated, and saturated fatty acid. Each oil is categorized based on which fatty acid is most prominent in it. Different oils have different qualities that make them better for certain uses. In this experiment, we will be evaluating palm oil, olive oil, canola oil on their acid value, peroxide values, and degree of saponification. The material we will need in this experiment will be acetic acid, ethanol, 0.1 normality sodium hydroxide solution, potassium iodide solution, phenolphthalein indicator, 20% sodium hydroxide, 0.01 normality of sodium thiosulfide solution. Determination of acid value. Acid value is defined as the weight of KOH needed to neutralize the organic acid present in 1 gram of fat. The acid content of edible fats is given by the quantity of free fatty acid deriving from the hydrolytic density of triglyceride. Acidity represents a basic indicator of the genuineness of the product. The test is particularly important during the refining of oils and fats, for the assessment of the processing cycle, and for the definition of the product categories. So let's get started. First of all, 3 grams of oil sample was weighed into a conical flask. 30 ml of ethanol was added into the sample and then shaken well to dissolve the sample. The sample solution was boiled for 5 minutes and cooled. 1 ml of phenolphthalein indicator was added into the sample solution. The sample was titrated with 0.1 normality sodium hydroxide solution until a permanent light pink color appeared. The acid value was estimated using the following equation. The result shows that virgin olive oil shows the highest acid value among the 3 samples. Canola oil shows the second highest acid value, while palm oil shows the lowest value. The level of acid value indicates degree of hydrolytic rancidity of the oil. The acid value in palm oil is greatly reduced by the refining process used for most vegetable oils. Virgin olive oil are not exposed to such processes, so the free fatty acid in the oil are considerably higher. Moving on, determination of peroxide value. Peroxide serves as a useful indicator of the extent of oxidation of lipids, fats, and oils. The peroxide value shows the degree of peroxidation and measures the amount of total peroxides in the substance. It has been associated with the rancidity in lipid-containing fruit products. Unsaturated free fatty acids in the oil react with oxygen and form peroxides, which generate volatile substances responsible for a typical musty or rancid bad oil smell. So an elevated level of peroxide indicates an oil has been damaged by free radicals and beginning to go rancid. The peroxide value is determined by measuring the amount of iodine which is formed by the reaction of peroxide with iodide ion. The iodide liberated is then titrated with sodium thiosulfate solution. 5 grams of oil samples was weighed in a conical flask. 30 ml of acetic acid was added into the oil sample and mixed well. .5 ml of potassium iodide solution was added and the solution was shaken for 1 minute. .30 ml of distilled water was added into the sample solution and shaken well. The iodine was then titrated with 0.01 normality of sodium pyrosulfate solution until a formation of a lipid layer. Peroxide value can be calculated using the following formula. Based on the results, olive oil has the highest peroxide value followed by palm oil and the lowest was canola oil. This indicates that olive oil has high degree of unsaturation and are more susceptible to auto-oxidation. Olive oil should not be stored for a long time because of deterioration. Next, determination of degree of saponification. Saponification is the hydrolysis of fats or oils under basic condition to afford glycerol and the salt of corresponding fatty acid. The saponification value represents the number of milligrams of the base required to neutralize a fatty acid resulting from the complete hydrolysis of 1 gram of fat. It gives information concerning the character of the fatty acid of the fat. The longer the carbon chain, the less acid is liberated per gram of fat hydrolyzed. The long-chain fatty acid found in fats have low saponification value because they have fewer COH group and therefore high molecular weight. The principle of it was that fats upon alkali hydrolysis yield glycerol and soap. First of all, 2 grams of oil was weighed and pipetted into the test tube. 4 ml of 20% sodium hydroxide solution was added into the test tube. Followed by 2 ml of ethanol. And the solution is mixed well. The test tube were placed into the boiling water for 15 minutes. After heating, the test tube was cooled down and 5 ml of water was added. The tube was shaken vigorously for 5 seconds. And the degree of saponification was observed and recorded. Based on the result, the degree of saponification was highest in canola oil, followed by palm oil, and the lowest was olive oil. It indicates that canola oil has shorter chain of fatty acid, while olive oil has longer chain of fatty acids. Therefore, we can conclude that olive oil has the highest acid value and peroxide value, while canola oil has the highest degree of saponification.